Okay, now the next thing we're going to talk about is the reciprocating piston. Reciprocating means going up and down or back and forth. Now you're going to have to understand what the piston job is and the components. Really basic stuff. We have the intake valve here that lets in air-fuel mixture. We have the exhaust valve that exhausts the burnt fuel. Springs keep the valves closed. Here we have the piston pin, connecting rod bearings, the crankshaft. And here is the cylinder. The piston rod up and down there, that's your cylinder. This little area here is the combustion chamber. When the piston is all the way up to the top, it's called top dead center. And the piston at the bottom point is called bottom dead center. Okay. Also, when the piston is going up, it's at the top point, and the spark plug ignites the air-fuel mixture. This little area is the combustion chamber. That's where the air-fuel mixture is burnt or ignited. Sometimes you might hear the term 8, 10, 5 degrees before top dead center. As this piston is traveling up, and 5 degrees before it gets to top dead center, it ignites the air-fuel mixture. I just picked 5 degree, 5, 8, 10, 12, depends on the manufacturer. This is a car with time. You can just adjust the time. But it usually ignites the air-fuel mixture a certain amount of degrees before it hits top dead center. So for example, it was 5 degrees before top dead center. Before this piston gets to the top, 5 degrees before it gets to the top dead center, it ignites the air-fuel mixture. Next thing is the 4 strokes. Now, understand this 4 strokes are intake, compression, power, exhaust. The piston starts at top dead center. As it starts to come down, the intake valve opens up, air-fuel mixture comes into it to fill the cylinder. As the crank starts to rotate, it starts to go back up. It compresses that air-fuel mixture just before the ignition. It takes the temperature just below ignition point. So when you get to top dead center, it starts to compress it. Just before you get to top dead center, current runs through the wire to the plug and ignites it. Then you get a small explosion when it burns the air-fuel mixture. That source of power is created. It will push the piston back down. Power stroke. The piston now being pushed back down. As it's going down, it's burning the air-fuel mixture. Now, after the air-fuel mixture is burnt, and hopefully it burns almost completely, the piston goes back up, and the exhaust valve opens up, and the air-fuel mixture that was burnt from the power stroke leaves the exhaust valve. Leave past the exhaust valves. So in this case here, again, we've got an intake, compression, power, and exhaust strokes. It's a 4-stroke engine. So the 4-stroke internal combustion engine, you see we start with the block design. You got different blocks, different engine parts, engine configuration, V6, inline, 4 cylinders, cylinder heads, and valve timing. Engine configuration, overhead cam, dual overhead cams, overhead valves, flatheads, F-blocks. I haven't seen that in a while. Here's a picture of dual overhead cams. Here's the exhaust cam. This is the intake cam, intake manifold. Here's the exhaust cam, exhaust right here. This right here is the cam lobe to open up the valves. Here's an overhead valve configuration. Here's my pistons. Here's my cam gear. Here's my crank gear. It's a 2-to-1 revolution, meaning that the crankshaft rotates 2 times per revolution. Here's the piston. Here's my valves overhead. Springs, connecting rod, push rods. Again, Look at the crankshaft. That's why it's 2 to 1. Look at the crankshaft. It's much smaller than the camshaft. That's why it's a 2 to 1 revolution. And that's why the crank rotates twice per revolution. Here's my timing chaining. I have a belt or a chain. The alignment of the crank and cam is very important. That's called valve timing. Here's my cam here. Here's my cam lobes. The cam lobes are very important because that opens up that pushes on the lifters will push the push rods in some cars, connects to the rocket and opens up the valves. The duration, or how long the valves are open, all depends on the cam lobe. And up here we got our rockers, adjustment here, the valve clearance, valve springs that closes the valves, intake, exhaust valve. It's a flathead straight 8 engine. It's a crankshaft, harmonic balancer, flywheel, journals are the connecting rods and the piston sits on. Here's my camshaft. You can see the lobes that open up the valves. These are the journals. Here's the lobes. That's the lobe configuration, a geometry. There's the top of a piston. They all got different designs. There's a piston head. You got piston rings. The first two rings are compression. Then the third ring is oil. As you can see here, you never want, when you're installing piston rings, these two gaps never align like this. And you'll lose compression if it was. Then you got your oil rings. I'm gonna go back to it. Like I said, this is never aligned like this. So if this gap was here, the top gap has to be either over here, here, or here. So you won't lose compression. Now, every manufacturer does it differently, but they never align like this. Here's the piston and the rod assembly. Let's see. Here's an inline engine. And there's a V engine. Inline means it's straight like this. The V shape, you can see, shape of a V. It's a V8. 4 on this side, 4 on this side. So remember, the degrees of rotation per stroke, determined by the number of cylinders. A 2 crank revolution per cycle. 360 degrees per rotation. 720 degrees divided by the number of cylinders. Okay, so just a reminder, the four strokes on a reciprocal type engine is going to be intake, compression, power exhaust, intake valve, exhaust valve, pistons internally. Oops. The crankshaft is a 2 to 1 ratio. Here's the camshaft. Camshaft gear is much smaller than the camshaft gear is much larger than the crankshaft gear, as you see here. That's your crankshaft here. And let's see. There's a V engine, inline engine. And the degrees of revolution per stroke are determined by a number of cylinders. So remember, it's a 2 crankshaft revolutions per cycle. Okay, that's a basic overview, a review for class. You have any questions? Look me up in class.